Hey, what's good? I'm Dr. Vibe, your physical science tutor over here at Tuff AI Learning Academy. We're about to make science hit different today. Atoms, forces, energy, reactions, all of it. I'm going to break it all the way down so it actually makes sense. No cap. So tell me, what we working on today?
Hi, my name is Donald, and I want to know more about microwaves and sound waves.
Alright, I see you. We diving into the world of waves, microwaves and sound waves. Let's get it. First up, microwaves. These are a type of electromagnetic wave, just like light, but with a longer wavelength. They're all about that cooking life, heating up your food by making water molecules vibrate. That's why your leftovers get all hot and steamy in the microwave. Now, sound waves are different. They're mechanical waves, meaning they need a medium to travel through, like air, water, or even solids. Sound waves move by compressing and rarefying the particles in that medium. Think of it like a crowd at a concert. When one person jumps, they bump into the next, and the energy travels through the crowd. So what do you want to know specifically about microwaves and sound waves? We can break it down further.
How microwaves and sound waves work.
All right, let's break it down step by step. Microwaves. 1. What they are. Microwaves are part of the electromagnetic spectrum, just like visible light, but they have longer wavelengths. They sit between radio waves and infrared waves. 2. How they work. When you pop your food in the microwave, it sends out these microwaves. Here's the magic. These waves hit the water molecules in your food. 3. Vibration. The microwaves make those water molecules vibrate super fast. This vibration generates heat, and that's what cooks your food. So it's not the microwaves heating the food directly, it's the water molecules doing their thing. 4. Energy transfer. The energy from the microwaves gets transferred to the food, raising its temperature and cooking it evenly, if you do it right. Sound waves. 1. What they are. Sound waves are mechanical waves, meaning they need a medium, like air, water, or solids, to travel through. They're longitudinal waves, which means the particles of the medium move parallel to the direction the wave travels. 2. How they work. When something makes a sound, like a speaker or a person talking, it creates vibrations in the air. These vibrations compress and rarefy the air particles. 3. Compression and rarefaction. Think of it like a slinky. When you push and pull on one end, the coils move back and forth. In sound waves, when particles get pushed together, that's compression. And when they spread apart, that's rarefaction. 4. Traveling through mediums. Sound travels fastest through solids because the particles are closer together, allowing the vibrations to pass through more quickly. In air, it's slower, and in water, it's faster than in air but slower than in solids. So, microwaves cook by exciting water molecules, while sound waves travel by vibrating particles in a medium. You feeling this? What else you want to dive into?
What's the difference from microwaves and sound waves?
Aye, let's break down the differences between microwaves and sound waves so it's crystal clear. 1. Type of wave. Microwaves. These are electromagnetic waves. They don't need a medium to travel. They can move through a vacuum, like space. Sound waves. These are mechanical waves. They need a medium, like air, water, or solids, to travel through. No medium, no sound. 2. Wave properties. Microwaves. They travel in a straight line and can be reflected or refracted. They have longer wavelengths and higher frequencies than visible light. Sound waves. They are longitudinal waves, meaning the particles of the medium move back and forth in the same direction as the wave travels. They have shorter wavelengths and lower frequencies compared to microwaves. 3. Speed. Microwaves travel super fast. At the speed of light, about 3.0 miles in a vacuum. Sound waves travel slower, around 343 miles in air, faster in water, and even faster in solids. 4. Energy. Microwaves carry energy that can heat up food by vibrating water molecules. That energy can penetrate materials like glass and plastic. Sound waves carry energy through vibrations, but they don't heat things up like microwaves do. Instead, they create pressure changes that we perceive as sound. 5. Applications. Microwaves used in cooking, radar technology, and communication, like cell phones. Sound waves used in music, communication, sonar, and medical imaging, like ultrasounds. So, in a nutshell, microwaves are electromagnetic, can travel through a vacuum, and are all about heating things up. Sound waves are mechanical, need a medium, and are all about vibrations that we hear. You feeling the difference? Any other questions on your mind?
What's the difference? Is microwaves and
Gotcha. Let's clarify the differences between microwaves and sound waves in a more straightforward way. 1. Wave type, microwaves, electromagnetic waves. They
It stops. Stops sharing. Okay, stop sharing. What else? Oh, and stream. I got it. This X.
It wasn't sharing.
It was.
Okay. Now, you did science and math, right? Those are two important subjects. We want to get you to understand better. When you go back to school?
What's today?
There's the 19th.